is functions. Thinking of a function as a machine as such that maps numbers into a codomain. So here's a few examples. -2, and our function is x is 1 over x. So we plug in this in and we'll get -1/2 for our function. Or likewise 0.12, x on y goes to y. So it's only the y here. And we know y equals 2 and so on. So here's a definition. A function f is defined by specifying a set A called the domain of f, a set B called the codomain of f. Now the rule is x goes to f of x. That associates each element x contained in A with a unique element f of x contained in B. The element f of x is the image of x under f. So f where A goes to B and x goes to f of x. Now here's an example. Real functions. R, don't forget this is the reals minus without the 0. And it's a function of R. In this case 1 over x, x 1 over x. And G, r to r of x 2x minus 5. Remember from set theory that this, I've shown this to be the case. Now the distance formula f, r squared minus r, x on y, it becomes the square root of x squared plus y squared. An example of transformation function. These are all just very quick, short examples of what we mean by these functions. A transformation function, we're mapping f such that it maps r squared to r squared of xy is x plus 2y. So this is just transforming this to here position on the graph. Should be straightforward. So functions are basically a mapping. I should have said that from the start. It's a mapping. Now reflection functions. F such that r squared goes to r squared, xy goes to negative xy, xy goes to negative xy. So under the function we're starting with this, and from this function we're going down here to this. So this is the reflection function as the example. Now we're inverse functions. The definition, let f be a mapping from A to B, be a one-to-one function, and then f as an inverse function of the inverse f such that f of A goes to A with the rule that the inverse of f of y equals x, where y equals f of x. Now composite functions. F such that r maps to r of x goes to x squared, and g r goes to r of x goes to 2x minus 5. So we'll picture this here, g o f as our composite functions. 2, we plug in the value 2, so x squared. Then there's the 4 here, because 2 squared equals 4. Then we're feeding this into the g now, so we get 3, because 2 multiplied by 4 minus 5 equals 3, and this is what we're doing here. So when 2 is fed into the machine, it is first squared by f to produce 4, then 4 is processed by g to give 2 multiplied by 4 minus 5 equals 3. So an example here, f, we're mapping r squared to r, xy to x minus y, hence GOF equals this function here, as we're mapping these two. So that's functions and composite functions. Please do like and subscribe.